Hello friends, myself O.D.E presenting my one more video on Euler's modified method. Let us solve differential equation dy by dx is equal to minus xy square. Condition y at 0 is equals to 2. Then find y at point 1 and y at point 2 by Euler's modified method. Here given differential equation is dy by dx is equal to minus xy square. We call this as f of xy. And condition is x0 is equal to 0. Corresponding y0 is 2. And to determine y at point 1 and y at point 2, let's consider h as a point 1. Difference between these two. And therefore, we start with initial approximation by Euler's method. y10 is equal to y0 plus h f of x0 y0. Using this, we find the first approximation, initial approximation for y1, and therefore y0 is 2, h is 0.1, f of 0 comma y0, y0 is here 2, and therefore it is 2 plus 0.1, f of xy is minus xy square, therefore 0 into 2, we get that term as 0, and therefore value is 2. X1 is x0 plus h, x0 is 0, h is 0.1, and therefore we get that x1 as 0.1. When applying Euler's modified by Euler's modified method, formula is y1 and its I plus first approximation is equal to y0 plus h by 2 multiplied by f of x0 y0 and plus f of x1 y1 and its ith approximation. We call this as equation number 1, with I is equal to 0, 1, 2 and so on. Therefore, if we put I is equal to 0, we get y1 1 first approximation as y0 plus h by 2 multiplied by f of x0 y0 plus f of x1 and y1 raised to 0 means 0th approximation or initial approximation for y1, and therefore it is equals to y0 is 0, h is 0.1 by 2, f of x0 is 0, y0 is 2 plus f of x1 is 0.1 and y10, the value of y10 is 2, and then finding this f of xy by that given function or given differential equation. Therefore it is 2 plus 0.1 by 2, it is 0.05 multiplied by f of 02, f of 02 is 0 minus xy square, x is 0, therefore that value is 0, minus 0.1 into y square is 4. And if we simplify it by calculator, we get the value, therefore it is 0.4 with minus sign multiplied by 0.05 plus 2 is the first approximation for y1. Then we put I is equal to 1 to get the next approximation we have. Substituting I is equal to 1 in this formula, we get second approximation of y1 as y0 plus h by 2 multiplied by f of x0 y0 and plus f of x1 is 0.1 and y1 first approximation of y1, and then substituting the corresponding values we get y0 is 2, h is 0.1 by 2, f of x0 is 0, y0 is 2, f of x1 is 0.1 and 1.980. It is equals to 2 plus 0.1 by 2, we get 0.05. F of 02, as x is 0, this term becomes 0, value is 0. 0 into y square, 2 square, 0 multiplied by 4, we get 0, plus minus xy square, therefore that value is with minus sign, 0.1 into 1.980 whole square and then simplifying it by calculator we get again it is coming as 1.980 as the value of y1 2, second approximation of y1 2, and as y1 1 and y1 2 are same 1.980, we stop that iterative procedure and therefore we get y1 nothing but y at x1 is y at 0.1, means the value of y at 0.1 as 1.980 is the value for the first y at 0.1. Then we require to find y at 0.2, means we have to repeat the same steps once again by considering initial value x0 as 0.1 and the corresponding y0 as 1.980 we get. Therefore, to determine the value of y at 0.2, we consider x0 as 0.1 and corresponding y0 as 1.980, and with these two values we try to find out the initial approximation by Euler's theorem. y10 is equal to y0 plus h f of x0 y0, and therefore we have y0 is 1.980, h is 0.1, f of x0 is 0.1 and the corresponding y0 is 1.980, and therefore that value is 1.980 plus 0.1 multiplied by minus xy square, x is 0.1 and y square means 1.980 square, and then simplifying it by calculator we get that value as 941 is the initial approximation for y1, and using this we try to find out the next approximation by applying this Euler's modified method formula, as y0 plus h by 2 f of x0 y0 and f of x1 and y1 initial approximation y1 0. Substituting the corresponding values, we get y0 is 1.980, h is 0.1 by 2, f of x0 x0 is 0.1, corresponding value is 1.980 plus f of x1 y1, x1 is x0 plus h, therefore a new x1 is x0 plus h, x0 is 0.1, h is 0.1, and therefore we get that value as x1 as 0.2, and therefore substituting that value of x1 here, we get f of 0.2 and the corresponding y10 is 1.941. Performing by calculator, we get 1.980, 0.1 by 2 we get 0.05, this one is minus xy square, x is 0.1, y square is 1.98 square, again minus xy square, x is 0.2 multiplied by square of this, that is 1.941 square, and then performing by calculator, square of this multiplied by 0.1, square of this multiplied by 0.2, and adding, multiplying it by 0.05 and adding with 1.980, we get that 1.923 is the first approximation. And then substituting I is equals to 1 to get the next approximation. Substituting I is equals to 1, 1 plus 1 we get y1 2, y0 plus h by 2, f of x0 y0, f of x1 y1 raised to 1, first approximation. And therefore substituting the corresponding values, we get y0 is here 1.98, h is 0.1 by 2, f of x0 is 0.1, y0 corresponding is 1.98 plus f of x1 is 0.2 and y11, the previous value of y1, 1.923, 1.923, and then finding this function value by applying this result, we have 1.98, no change, 0.1 by 2 we get 0.05, xy square with minus and minus 0.1 multiplied by 1.98 square, then minus again xy square, x is 0.2, therefore 0.2, and y square means 1.923 square. Simplifying it by calculator, we get means square multiplied by 0.1, square multiplied by 0.2, add multiplied by 0.05, and then finally adding with 1.98, we get that value as 1.923 is the value of y12, and as y11 and y12 are equal, that is equals to 1.923, we stop the iterative procedure, and therefore we have y1 means y at x1 and x1 is 0.2. Therefore, y at 0.2 we have the value as 1.923. As the required value or required answer for this y at 0.2 by applying Euler's modified method formula. In my next video, I will discuss another important technique, that is Runge-Kutta fourth order method to determine the solution of ordinary differential equation, numerical solution of ordinary differential equation. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.